Do you want to learn about the ionization of water?
It's definition girl, do you have something to tell us?
Acids and bases. Acids and bases. One is yes and the other one neutralizes.
Strengths of acids and bases.
What makes an acid strong or weak?
Well, you see, Matthew, the strength of an acid depends on the number of hydronium ions present in the solution. The more hydronium ions present, the stronger the acid.
What makes a base a weak base or a strong base?
A strong base is one that reacts completely. It goes through complete ionization, producing more of the hydroxide ions. Weak bases do not go through complete ionization and produce few hydroxide ions.
What is the difference between an acid and a base?
Well, Cody, the basic difference between acids and bases is that acids produce hydronium ions, while bases produce hydroxide ions. Acids turn blue in litmus paper, and bases turn red.
Very good, very good.
Also, acids are 1 through 7 on the pH scale, and bases cover 7 through 14.
Excellent.
Can you pause?
What are some types of strong acids and weak acids?
Those with a small Ka value which favor the reactants are known as weak acids. These include hydrogen peroxide, hydrogen sulfide, and the weakest acid of all, ammonia, NH3. Strong acids are those with a high Ka value which favor the products and include nitric acid, sulfuric acid, and the most acidic, perchloric acid. And the lemon juice that we used earlier was an acid too.
Excellent. All right.
What are some types of strong and weak bases?
Well, you see, Matthew, those with a high Kb value are strong bases and include sodium hydroxide. Those with a small Kb value are a weak base, such as ammonia, which when combined with H2O becomes a weak base from a weak acid. Roids are an example of this, and this is an example of a strong base which conducts more electricity in the solution, and this is an example of a weak base, which is a dimmer light bulb.
Acids and bases. Acids and bases.
Do you want to learn about the ionization of water?
Water is considered a non-electrolyte. Non-electrolytes typically will not ionize. However, a few molecules do react to form ions. This is represented by the equilibrium reaction of 2H2O equals H3O plus OH negative. Therefore, an equilibrium constant for the water can be determined by the equation Keq equals the concentration of H3O plus times the concentration of OH negative over the concentration of H2O squared.
KQ, H3O plus, OH minus. Nice. Products of reactants.
No problem.
Kw is the combined term of Keq and H2O. Thus, Keq and the concentration of H2O squared equals H3O, the concentration of H3O and the concentration of OH negative. And it can also be written Kw equals the concentration of H3O plus and the concentration of OH negative. Oh, the value for Kw at 25 degrees Celsius has been determined to be 1.0 times 10 to the negative 14. Thus, the concentration of H3O plus and the concentration of OH minus equals 1.0 times 10 to the negative 14.
All acids, when added, increase the concentration of the H3O plus ion within the system and decreases the OH negative of the system, and vice versa when adding bases.
After the addition of an acid or a base, the Kw is still Kw equals H3O plus times the concentration of OH minus, which equals 1.0 times 10 to the negative 14.
If the H3O plus increases and the OH negative decreases, the acidity of the solution will change. So if the concentration of H3O plus is greater than the concentration of OH negative, the solution is acidic. If the concentration of H3O plus is equal to the concentration of OH negative, the solution is neutral. If the concentration of H3O plus is less than the concentration of OH negative, the solution is basic.
What does the effect of the temperature have on Kw? The equation of the ionization of water is 2H2O is in equilibrium. 2H2O is in equilibrium. 2H2O is equilibrium at H3O plus OH minus. The delta H equals positive 57.1 kilojoules per mole.
This means it's endothermic. Therefore, when the temperature is increased, the equilibrium shifts to the product or to the right. Because the concentration of H3O and the concentration of OH increases, so must the Kw. So if temperature decreases, as does the Kw, and the concentration of H3O and the concentration of OH, this is how the values of Kw at various temperatures. Assume in all equations the Kw equals 1.00 times 10 to the negative 14, unless a different temperature is specified.
This is the chart of various temperatures until she walks away.
Okay.
See, various temperatures, various things.
What is the OH, or the concentration of OH in the solution described in the question before?
Who decided it?
Well, this is doing the question on the board.
Kw equals 1.0 times 10 to the negative 14.
H3O equals 1.0 times 10 to the negative 1 mole. Polarity.
OH equals the question. Shut up. I heard that.
So we're filling in our Kw values.
Indeed.
We've got the hydronium ion value, and we're trying to solve for concentration of OH ion. And we've done it. And there it is.
Therefore, in this equation, the concentration of the OH is 1.00 times 10 to the negative 13.